Imagine this: a kite soaring high in the sky on a breezy afternoon. The kite string forms a slant line from the ground to the kite. Now picture an invisible line from the kite straight down to the ground, forming a right-angled triangle with the string and the ground. This scenario showcases the magic of Pythagoras' theorem and trigonometry, two fundamental concepts in mathematics. Pythagoras' theorem, named after the ancient Greek mathematician Pythagoras, states that in a right-angled triangle, the square of the hypotenuse's length, the side opposite the right angle, equals the sum of the squares of the other two sides. Considering our kite scenario, if the string measures 20 feet and the vertical distance from the kite to the ground is 15 feet, the distance from the kite holder to the point below the kite on the ground can be found using Pythagoras' theorem. On the other hand, trigonometry, a branch of mathematics, deals with the relationships between the sides and angles of triangles. Trigonometric functions such as sine, cosine, and tangent help in determining these relationships. In our kite example, trigonometry can help find the angle at which the kite is flying by using the lengths of the sides of the triangle. Now consider another scenario: a baseball player trying to catch a high ball. The player estimates the ball's trajectory, runs a certain distance, and positions himself to catch the ball. This situation involves both Pythagoras' theorem and trigonometry. The player subconsciously creates a right-angled triangle with the initial position of the ball, its highest point, and its landing point. By calculating the distance he needs to run one side of the triangle and the height he needs to reach the other side, he can place himself perfectly to catch the ball. Trigonometry helps in calculating the angle at which he needs to jump to catch the ball. In both scenarios, Pythagoras' theorem and trigonometry are instrumental in determining distances, heights, and angles. They work together, complementing each other in solving real-world problems. For instance, architects use these mathematical principles when designing structures. They calculate distances, heights, and angles to ensure that buildings are structurally sound. Similarly, pilots and ship navigators use trigonometry and Pythagoras' theorem to calculate their route and distance to their destination. So the next time a kite soars in the sky or a baseball player runs to catch a high ball, remember the invisible right-angled triangles and the mathematical principles at play. Pythagoras' theorem and trigonometry, though seemingly abstract, are deeply rooted in our daily lives, making the world around us a giant geometric playground.